Okay, let's unpack this. Have you ever really stopped to think about where your important digital files truly live online? I mean, not just that they're stored somewhere, but how securely and who's actually keeping tabs? Today, we're diving deep into something that could, well, really shake up digital storage. Decentralized storage networks, DSNs.
Exactly. And our guide for this is a really interesting new paper. It's titled Adaptively Secure Blockchain-Aided Decentralized Storage Networks, Formalization and Generic Construction.
Hmm.
It's by Yangyu Su and colleagues, fresh out on the Cryptology ePrint archive. They're really getting into the weeds on some complex security issues with DSNs, proposing, well, a pretty robust blueprint for the future.
Right. So our mission here is to figure out, what exactly are DSNs? What are the sneaky problems they run into? And crucially, how does this new research offer what they call an adaptively secure solution? The aim is making your data safer, more reliably there when you need it.
Okay, the basic idea of a DSN that uses decentralization, right? Which fundamentally is about not putting all your eggs in one basket. No single point of failure. And in the data world, that translates to things like resisting censorship, making actions publicly verifiable, and just better protection against losing data altogether.
Yeah, that makes sense.
And what's quite neat here is how DSNs work. They get lots of different computers, nodes, to keep copies, replicas of your data. The promise to you, the user, is that these copies are genuinely kept safe for the time you've agreed on. But yeah, that setup brings its own technical headaches.
Like what? I mean, if your data's scattered everywhere, how do you know those servers are really holding on to it? And, what about getting it back? Fairly. Say your contract ends, you've paid up. How do you ensure you actually retrieve your data without hassle?
That's a huge point and leads to this question. What if you have a clever attacker, someone they call an adaptive adversary? This isn't just a basic attack. It's a server, maybe, that learns, adapts its strategy to try and cheat the system. Maybe pretend it's storing data when it's not.
Okay, that sounds tricky.
Yeah, and previous designs, well, they didn't always formally define security against these smart attacks very well. And kind of surprisingly, they hadn't fully tapped into something like the extended UTXO model, the sort of accounting system used by Bitcoin or Cardano.
Ah, the EUTXO model.
Right,
Right.
exactly. It offers this deterministic verifiability for payments, for collateral, things you really need to build trust and accountability into a DSN.
Okay, so this is where the new paper comes in. This is where it gets really interesting.
Precisely. Sue and the team are proposing what they claim is the first adaptively secure UTXO blockchain-aided DSN.
Whoa, okay, break that down. What does adaptively secure and UTXO blockchain aided mean in practice here?
It means they've designed a DSN that uses that robust EUTXO blockchain model as its backbone for trust and verification. And the adaptively secure part means it's built to withstand those clever, evolving attacks we talked about.
And the key seems to be this automatic verifiability thing they mention.
Yes, that's the game changer. The network itself automatically generates and publishes proofs onto the blockchain. Proofs that guarantee your data is being stored correctly. And the best part, it happens without any interaction needed from you, the data owner. It just runs constantly checking.
Okay, so no more manual checks or just hoping the servers are doing their job. The system polices itself publicly on the blockchain.
That's the idea. Their paper lays out a really formal description, a 4-phase protocol. Setting things up, getting the data delivered, then this automatic testing phase with proofs and challenges, and finally, data retrieval.
And this adaptive replication soundness you mentioned, that's the new security definition.
Right. Think of it as the system shield against those adaptive adversaries. It specifically stops them from, say, deleting replicas, but tricking the system by reusing old proofs or exploiting how randomness is generated for challenges. It ensures the proofs really mean the data is there now.
And they actually tested this. It's not just theoretical.
Yeah, they ran simulations. They modeled attacks like subliminal channels or using compressible randomness ways an adversary might try to cheat on proofs and other systems. Their experiments showed why these new, tougher security definitions are crucial. The proofs need to be short, efficient, yes, but also non-malleable, unchangeable once created.
Non-malleable, so tamper-proof.
Exactly. So putting it all together, it's a rethink of DSNs using that EUTXO blockchain foundation to give strong security guarantees and a rational incentive structure. Everyone's incentivized to play fair.
So wrapping this up, what's the big takeaway for us, for anyone using online services?
Well, it's a blueprint, really. A path towards a future where your digital stuff isn't just stored somewhere vaguely out there. It's stored in a way that's verifiably secure, provably safe using financial mechanisms built right in to ensure accountability in a decentralized world.
Yeah, it really makes you appreciate the complexity behind the scenes. Getting these decentralized systems right, especially the security definitions, is just so critical for the services we're starting to rely on more and more.
Absolutely. The level of detail in designing these protocols is immense.
It really is. So, maybe something to think about. In this evolving decentralized landscape, what does making your own data truly adaptively secure actually mean to you? What level of proof would make you feel completely confident? Something to chew on.